Hello, young chemists. What I'm going to do for you now is I am going to give you some tips and hints to navigate your current quest so that you have success the second time that you take it. What I do know over the past 2 weeks, we've been talking about atomic structure specifically and how to read the periodic table, and then what we can find knowing certain vocabulary terms and certain pieces of an atom that we are able to use the periodic table for. So the first thing that I'm going to discuss with you that I know will be on your quest is atomic structure. If you look here at this example that I have, there are really 3 pieces, subatomic particle pieces, that every atom has. And the first one's going to be an electron, and if you notice, electron has a negative charge. What I also want you to know of electron, that it is light as a feather, and that's why it resides in the cloud. So if you could think, electrons, they're not going to be designated an atomic mass unit because they're light as feather and they reside in the cloud. Protons, on the other hand, are fatty McFaddersons, so they fall to the center, they fall to the nucleus of an atom. They're heavy, they're fat, they sink, they have 1 atomic mass unit. Neutrons are the same exact way. Neutrons are fat, they're heavy, they fall to the nucleus of an atom, and so we give them a designation charge of 1 AMU, which stands for atomic mass unit. Proton, the easy way to know that that's a positive charge, like P for proton, P for positive, that's how I really help distinguish between the charges of subatomic particles. What I need you to know at this point, that the number of protons is what designates an element. It's the fingerprint. You cannot change that. If you change proton count, you're changing the element. So that's a big, big no-no. So we can actually do 2 things to an atom. We can actually add or take away electrons. Okay? We can add or take away neutrons, but we cannot add or take away protons. Once we do that, it changes the element on its whole, and we'll talk about that later on in the semester. Another big aha moment is most atoms, just so you know, want to be neutral. So that means their proton count, when we're talking about normal, their proton count and their electron count is going to be equal to each other. The atom, once again, wants to be neutral. So what I need you to understand, that electron count and proton count, they really want to match each other. As soon as I start adding more electrons to an atom, that is an ion. As soon as I take away electrons from an atom, that is an ion, and we designate the name of that atom with either having excess electrons, which would give it like a negative whole charge, or it has a lesser amount of electrons, which means there's too many protons, which designates that atom as having a positive charge, okay? So that's called an ion. I stated that a little bit differently than we did in the lecture, because then maybe it'll click with some of you. But that's another vocabulary term that I know you'll need to know and be able to apply to certain questions. This is a brief description of what I just said in the previous diagram. You can go back to your teacher's lecture to be able to look at this and hear, again, maybe it restated in a different way, which is always good, hearing how other people describe things, because maybe it'll be a clicky aha moment to you. I just know that you're going to have to figure out what the atomic number plus, which is protons, plus the neutron count together is going to be giving the mass number. Okay, so mass number is equal to number of protons plus number of neutrons. So what I can actually do is manipulate this formula to find any one of the 3 pieces. Typically, you're going to find the number of neutrons. Okay, typically that's what's going to happen. Because remember on the periodic table, I give you mass number and I give you protons. So to find the number of neutrons, that's typically what I am going to ask you to find. And especially on this quest, I want you to be familiar with this. So that formula of mass number is equal to protons plus neutrons is manipulated right here for your ease. So I would write this down at this point so that you nail that question on the quest. So how do you know how to read the periodic table? What I tell my kiddos is when you get on a scale, that's your mass and the force of gravity, right? So when you get on the scale, you are never exactly like 107 pounds. You're always like a little bit extra. Does that make sense? Like if I get on the scale, I'll be 150.4 pounds. So if you're reading the periodic table and you're confused, if there's a decimal number after it, it's going to be atomic mass. It's gonna be, okay? Just go with that. That's a cheating method. This nice whole number that you see at the top of a periodic table, that's gonna be atomic number, and that tells you proton count and neutron count. Tells you proton count and neutron count. So this is how you read the periodic table. You will always have the element symbol on the periodic table, not necessarily the element name. Okay, you have to know the difference between ions and isotopes. So I stated this before, but I'll state it again. If an atom is going to be losing electrons or gaining electrons, it is an ion. It is an ion. So this is why we put this funny little comic up here in your lecture, which was almost 2 weeks ago now. So if an element loses electrons, it's not neutral anymore, correct? It's not neutral. It means it has more protons than electrons if it loses electrons. So that element is going to be designated as a positive charge. If for some reason an atom takes on electrons, that means it has too many negatives compared to its positives now. So we designate that atom as having a negative charge. So those are ions. So if you remember, there's two types. Cations has a plus sign in it. Cations, positive. Or you can think cat, paws, positive. Okay? And there's anion. Ooh, bad. Onion, anion, onion, negative, bad. So those are the two names that you'll need to be able to reference when we're discussing ions. Isotope, on the other hand, is when an atom is fat. Typically, the best example that I can give you is when an atom has too many neutrons. It's gotten fat. It's been through the periodic table of element restaurant one too many times. It has too many neutrons, and it is fat, and it's heavy. Okay? So to give you an example, see, carbon typically has 12 neutrons. Neutrons, by the way, remember, don't have a charge, so sometimes you'll see it designated as 0, because 0 is not a charge, okay? So C14 means that this carbon has added 2 neutrons. It's eaten way too many pieces of pumpkin pie. It is fat and it's heavy. Being able to reference that is very, very important. Okay, so an isotope is when an element has extra neutrons in its nucleus. And I can add as many neutrons as I want. It does affect the properties of that element, but I can do that because remember, the only thing that names an element, that gives its formal name, its fingerprint, is the number of protons. So again, I can add or I can subtract neutrons, and that's called an isotope. What we're going to do for finding atomic mass is we're going to watch this mini video.
Percent abundance and the mass of the naturally occurring isotopes of an element. The equation to calculate atomic mass is equal to the mass of an isotope times its percent, and you add that to the mass of another isotope times its percent. It's a weighted average, and we're going to divide it all by 100%. So mass times percent plus mass times percent, all over 100%. So here we go. We have boron 10 at 19.9%, so I'll just put 19.9%. and boron 10 weighs 10.013 AMUs. So I'm going to multiply those and add it to the 80.1% times the mass, which is 11.009 AMUs. And we're going to divide that all by 100%. So 10.013 times 19.9 equals, and we're going to add that to 11.009 times 80.1, and then we're going to divide that by 100. And we get an atomic mass of 10.81, and that's going to be AMUs. If it's the molar mass, the units just change to.
Okay, so finding average atomic mass is, you can actually, too, just so you know, he divided at the end by 100%. You can actually divide the abundance, if you want, in the beginning by 100 to get a nice small decimal. Some of you like to do it that way, and it doesn't matter for the process. Okay, now that I've given you those helpful hints, you can try your quest again, and I know that you can do it, and I wish you good luck.